A quiz? Yes, we are. All of you are on page 67. Now listen, please. You have already seen this. You have already seen this in the way we're about to do this. So everybody have a look here, right there. Is that factored or is that a product? That is factors. If you see factors beside each other like that at the beginning of a question, what should you do? Expand it. Since it is binomial times binomial, how many expansions am I going to need to do? 4, right? Technically. I've given you a shortcut for this, but we are going to do all 4. The first one we will do, it is the black. It is x times x, which is x squared. The second one is the red. X times negative 4 is negative 4x. The third one is the blue. 4 times x, positive 4x. And the fourth one is the green. 4 times negative 4, negative 16. Now, you then, of course, would collect your like terms to get x squared plus 0x minus 16. In reality, we would never write this. But I've used this on previous pages to show you what I'm about to teach you now, okay? This answer, in reality, we would write it as what? Cursill. X squared minus 16. And you would see the following. That number is some number squared. This number is 4 squared. And you would see, because I am subtracting, I have a difference of squares. Now you also should see the shortcut immediately, which I have shown you in the past already. X squared becomes x times x. 16 becomes 4 times 4. What is the shortcut quick pattern that we can use here?
Perfect square.
I take the square root of the first one. So if I take the square root, if I take the square root of x squared, and then I write it, what's the square root of x squared? X and x. And then I take the square root of 16, which is what? 4 and 4. 4, and I make one positive and one negative. That positive and negative allows for this to happen. Does everybody see? So, if I have any number that is a square, and I subtract any other number that is a square, all I have to do to factor it is take the square root of the first one and the square root of the second one, and then write them twice. One of them has a positive, one of them has a negative. Does everybody understand? It seems easy. We're going to do 3 or 4 in our heads right now before we do the actual work. Because it's so easy at the beginning that it tricks you into thinking that it's going to be that easy all the way along. Is everybody with me? So let's do a couple just in our heads, not notes. Don't write this down. Just use your brain. M squared minus 4. Is that a square? How do you know? Because it's got a little 2. Is that a square?
No.
How do you know? Because this is really 2 squared, isn't it?
Yes.
So that is a difference, yes? So since I know it is a difference of squares, I can take the square root of that. What is the square root of m squared? M. And then I can add the square root of that. What is it? 2. And then I write it again with the negative symbol. That's how easy this is. Everybody cool? Does order matter? No, of course not. Does the nature of the number matter? No. If it's a perfect square, you can do this. So let's try another one. Again, you were just using your brain. What if I had 25 minus y squared? Would that work?
Yeah.
Why? Because 25 is what really? 5 squared. And that's already squared because it says it's squared. So this would be the square root of the first one, which is
5
plus y, and then
5 minus y.
does everybody see?
Yeah.
Now let's change the nature of the number slightly. What if it was, and again, you're not going to write this down, 4a squared minus 4. Would that work? Yeah, you're right. I shouldn't have done that because you can GCF it. Let's make it 9. Would that work?
Yeah.
Yes.
Why?
Because 4 is a perfect square.
4 is a perfect square.
9 is a perfect square.
A squared is a perfect square. And 9 is a perfect square. So can I take the square root of that? What is it? 2a plus 3. And then?
2a minus 3.
Okay. Oh, I like where this is going. What if I gave you this? 16q squared minus 25p squared. What's that one going to be? Addison.
4q minus 5p. 4 or no,
5p.
I'm glad you changed the order here, Addison. Does this matter?
No.
Why not?
Because it's the same either way.
Because it's the same. 5 times 2 is the same as 2 times 5, right? Everybody good? Yeah? Everybody's able to do this just right out of their heads, right? Now there's a couple of things that will mess you up. What is the square root of 1? 1. Right? A lot of people say 1 is not a perfect square, but is it?
Yeah.
Of course it is, because 1 times 1 is 1. Right? Okay. The next thing that'll mess you up. What is the square root of 1/9? You know this.
1
No. What? I heard it at the back. 1/3. So what if I gave you 1/64th minus 4? 1/64th minus 4x squared. What would that one be? Amelia? 1/8 2x, and then everybody still okay? All right. Now the next thing that's going to mess you up is this. What is the square root of x to the 4th? Gersahill. X squared, right? Okay. What is the square root of x to the 6th? X cubed. All right. What is the square root of x to the 8th? X to the 4th. What is the square root of x to the 32nd? X to the 16th. What is the square root of x to the 64th? X to the 32. What is the square root of x cubed? Does that have a perfect square? No, because that is x, x, x. I'm looking for a pair, aren't I? Yes, I know it's naughty. I do it on purpose. I'm looking for a pair, aren't I? So I bring out 1x and I leave 1x there. Is that perfect? No. So tell me, what is it about that, and that make it work? And what is it about that makes it not? They're even. An even square root is always what? What is the relationship? The even square root is always what? Divided the original divided by 2. So what then is, and this is the last one we're going to do on our heads, x to the 8th minus 25y squared. Yeah. Try it, Garcille.
X to the 4th minus 5y.
And then
X to the 4th plus 5y.
did everybody follow all this in their heads? I didn't stress you out by making you write it down because all this is, you already know this, right? Like everybody, all of you have brought this to the party, right? This you may have forgotten, but of course you remember from our unit on roots that that is x, 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 x. You bring out 2 pairs of x, x squared, right? Everybody good? Okay, now that we are all on the same page, literally on the same page, stop it! Go to number 1. I get that a lot. Thank you for noticing, Garcille. It honestly makes me feel better. Is that a perfect square?
Yeah.
How do you know?
Divisible by 2 even.
Because the exponent is divisible by 2, right?
Yeah.
Okay. Is that a perfect square?
Yeah.
Why?
Because 1 times 1.
1 times 1. So what is the square root of this? Addison.
X to the 4th.
No. X to the 8th. Plus what? 1. And then what?
X to the 8th minus 1.
Now, what do you see there? It can go again, can't it? Can this one, can the pink one go again?
Yeah.
Why not, Garcille?
Because we can't do different with squares.
It's not a difference of squares, is it? That's a sum of squares. So this guy, we're stuck with him. But what can this green guy become?
X to the 4th
X to the 4th.
minus 1.
Well, I would do the plus 1 first. And then x to the 4th minus 1. Am I done?
No.
What do you see right there?
And divided it.
I can go again. X to the 8th plus 1. X to the 4th plus 1. X what?
To the second.
Squared plus 1 and x squared minus 1. Am I done?
No.
Why not?
That's the second.
Because that can go. X to the 8th plus 1. X to the 4th plus 1. X squared plus 1. And finally,
X plus 1.
and
X
minus 1. And now I'm done. Everybody cool?
We have to do the other one.
Just wait a sec. No, we're done here. Because these are all plus, right? We can't do the plus. Everybody understands why, correct? Okay. Again, don't write this down. X squared plus 1, right? So if we could do this, I would need this to be x squared plus 0x plus 1, right? Everyone's cool with that? So if I gave it to you as a trinomial, you would need numbers that multiplied to 1 and added to 0, wouldn't you? What are the factors of 1? 1 and 1, right? Will 1 and 1 get multiply to get me positive 1 and add to get me 0? No, because if it multiplies to positive 1, it's got to be plus 1, right? Well, 1 plus 1 is 2. It's not 0. With me? Okay, Myers, screw you. It's negative 1 and negative 1, because negative 1 times negative 1 is positive 1. Haha, I got you. Except what's negative 1 plus negative 1? Negative 2. Is that 0? No. So that's why the plus doesn't work. There's no way to get that. Cool? All right. Now, ladies and gentlemen, everybody followed this, right? Now, don't write this down. Would this work? Yes or no? Gersahil, you so far have gone, yes, no. Gersahil, what's the answer?
No.
Are you sure?
Yeah.
You're sure that, you're sure that it's not going to work? Or you're not sure and it is going to work? Is it yes? Is this one going to work? Yes or no? Just pick a choice and stick to it. Don't be a wuss.
No.
It's not going to work.
Won't work.
Are you sure?
Yeah, I'm sure.
100%?
Yes,
I'm your math teacher. Are you sure you want to base your relationship with me on this?
yes.
Does that work? Yes or no?
Yes.
Okay.
It doesn't work because you can't like multiply two numbers together. Oh wait,
It doesn't work.
I told you.
There is no square root of 2. That's why I did this whole thing over here. 2 doesn't have a square root. It's not a difference of squares. 2 has no square root. So this cannot be done. Could this be done?
Yeah.
Yes. What would that be? 2x 8th plus, and then
Same thing but minus.
2x 8 minus 1. Now do we have to stop?
Yeah.
Why?
You can't go here.
Because 2 has no square root.
Yep.
Okay? What if it was 16? What would it be?
4.
4x8 plus 1 and 4x8 minus 1. Is that one done? No. Why? Addison.
I don't know.
You just trying to fake me out? You put your hand up so you think that I think that you know the answer, and if I don't call on you, it's still in my head? Oh, Addison knew. I don't need to talk to him.
I thought you were done with your phrase, and I was going to put my hand up and ask, because I still understand why there was 2 8s. I was going to get you to explain that.
Well, what's x to the 8th times x to the 8th? It's x to the 16th, isn't it?
Yeah, I understand that. I just don't understand why you didn't keep going. Then you have underneath it x to the 8th and then x to the 4th.
Because x to the 8th is a perfect square and 1 is a perfect square, so I have to break it down again.
Yeah?
And then x to the 4th minus 1, perfect square minus a perfect square, so I got to break it down again. I got to keep breaking it down. Now, can I do this one again?
Yes.
Right, because 4 is a perfect square. Everybody good?
Yes.
That means you should be able to figure out all of these. Is this a perfect square? Is it?
Yes.
What's the square root of x squared y squared?
X and Y.
xy. Because x times x is x squared and y times y is y squared.
Yep.
Right? Does that have a perfect square root? What is it?
25.
15, because I told you to memorize the first 20 of them. And there it is. Is there any reason for you ever in this unit to say, Mr. Myers, did I do it right? No, why not? Why am I telling you that you don't need to ask me? Jacqueline, you can reverse it. Is xy times xy x squared y squared? Plus 15 minus 15, are they going to drop out? Yes, and then 15 times 15 is 225, so I'm good. Everybody okay? Great, let's do 3. Is that a perfect square? Yeah, it is. Is that a perfect square? Yeah, it is. So what's the square root of z to the 8th? Plus, what's the square root of 144? Nice. Then I write it again. Am I done? Look closely.
Yes.
Why, Braden?
Because 12 doesn't have.
12 doesn't have a square root, so I'm done.
Yay.
Why did you drop your zeal from arguing it?
So you don't think it's a 2. I know, I get a lot of that too. So far today, you guys have noticed I'm both clever and smart. Thank you. Now, somebody should remind me how funny I am.
You're so funny.
Thank you. Now, somebody remind me how devastatingly handsome I am.
I'm good.
No, I'm good.
What? What? Now somebody remind me about how strikingly intelligent I am. Oh, we've already done that one. Somebody remind me about how uproariously funny I am. Looks aren't everything, Mr. Myers. See how I did that right there?
Mr. Myers, how do you come up with your jokes?
Huh?
How do you come up with your jokes?
I'm devastatingly funny. And because I'm punishingly intelligent. How's that sound?
That's one way to put it.
All right. Okay. 4 is the hardest one you've seen. Yes, 4 is actually... It is, Jaden. And,
Is it though?
and Jaden, because you were able to sarcastically say, is it though?
You get to do it.
No. That's why it's the hardest one you've seen, and you can still say, is it though? Because it's not hard, is it? What is this? Is that a perfect square?
Yeah.
Why?
No, X doesn't, or I mean, 6 doesn't have a perfect square.
Yes, it does.
6 does.
Okay, Addison. What is the square root?
Exponent laws.
So, is that a perfect square? Is that subtraction? Is that a perfect square?
Yeah.
So what is the square root of the first one?
2x3 minus 5.
Why do you guys always do the minus first?
Because my negative minus 5y.
Okay.
The brackets around that. And then 2x3 plus 5y.
And are we done now?
Yeah.
Why?
Because 5 doesn't have.
5 doesn't have a root, and there's only a single y. You can't get a square root of a single variable. Everybody good?
Yeah.
Okay, now you are intelligent young people. When I leave this much white space, why do I leave that much white space?
So we can check our work.
So you can
We
work
can
later.
do longer.
To do more questions.
We can make our own questions up.
Almost all, you're the closest there. This was really easy, right? Like, let's be honest. No messing around. If you can do a square root in your head, you can do these. What if you can't do it in your head? Do we remember how to do square roots? We could break it down with factors and pull out the pairs, right? We could do it every number I could use, yes? Now, I want to show you something that looks a little funky. All right? From funky, but if Funke is the guys on Arrested Development, which is one of my favorite shows. Yes. Let's look. Is that a difference of squares? It is. Why? Gersahil. X minus 3 is in brackets, yes? You could expand this, and it would become x squared minus 9, yes? And x squared minus 9 minus 16 becomes x squared minus 25, doesn't it?
Yes.
Which is a difference of squares. It would be x, what? Plus 5 and x minus 5. Ease, bees, lemon, squeezy, right?
Easy peasiest.
Right?
Yeah.
Okay. Let me ask you this. What if I had... But is that right? Is that right?
Yes.
The question.
Is x
Yes.
minus 3 squared actually x squared minus 9?
No.
No, it's not. So, let me ask you this. Oops. Could you do that?
Why did you give it an
I'm just asking you, forget the green. Could you do this?
A? Yeah.
What would it be? Right? Everybody can do the blue, right?
Yes.
Okay. Now watch this. A equals x minus 3. a is x minus 3. Now it's a plus 4, a minus 4, right? But what does a really equal?
X minus 3.
X minus 3 plus 4. What's x minus 3 plus 4?
X plus 1.
Plus 1. And this is x minus 3 minus 4. What's that?
X minus 7.
X minus 7. Does everybody see that handy little trick?
Yeah, or any good you do.
I will.
X squared plus 9.
Now, no, you can't because, and I'll show you in a sec, okay? Actually, I'm going to show you your thing first, then I'm going to come back and do this again for you. So, Gersahil wanted to expand this, and then he made that high school mistake of distributing that 2 to both of them, right? Why is that a mistake? What do these brackets do to x minus 3? It holds it together as a group, yes? So x minus 3 squared is really x minus 3 times x minus 3, isn't it? Which is really x squared minus 3x minus 3x plus 9, x squared minus 6x plus 9, yes? Right? Everybody cool? So this is really this. And then I would take away 16, which would be x squared minus 6x minus 7. And then I could factor that by multiplying to negative 7 and adding to negative 6, which gets me this. But I submit, isn't this way shorter? All I did was take this, the thing I didn't like, and made it one thing. Now I have a squared minus 16. Do that in my head. A and a, square root of a, square root of 16. And then at the end, I put back in what a really is, and I fix it up. Does everybody see that shortcut? Do I need to use that shortcut, or am I allowed to expand it all the way down? Or do I even care? I don't care. Because the factors of negative 7 that add to 6 are 1 and minus 7, aren't they? So this would be x plus 1 and x minus 7. You do that work, the kid beside you does this work, and you both, ruins the drama. And you get that, and the kid beside you gets that. Who gets 4 out of 4? Both of you. Who is responsible for knowing their path to the end? You are. What works for you is what you do. All right? Jacqueline.
In the first equation of 3a's, why did you have negative 3 twice?
Because a was x minus 3, right? So x minus 3 plus 4, negative 3 plus 4 is 1. And then I have another a, so it's x minus 3, and the negative 3 minus 4 is negative 7. Everybody cool? Do I care how you do it? Not at all. But this can be very useful later on. All right? But that being said, you can always expand. But please notice it's a bit more work. Right? Addison.
Should you always use like a term just with like one letter?
I would because you could do this in your head, right?
Yeah.
You know this is the square root of the first one, a, and the square root of the second one. Then you just plug the a back in. All right? Everybody cool? All right, now listen to me carefully. Page 68 has mostly what we just did. All right? But I'm going to warn you. Some of the questions look like they won't work. But you have a mathematical piece of knowledge to do every question on page 68. I am not making it an assignment. You are just going to work on it. Okay? You're going to work on 68 now. Now listen to me. Tomorrow you're going to have a quiz on the two types of factoring that are on page 65. Page 65, that is your quiz. Please notice you have not had any quiz or assignment on difference of squares. All right? Actually, I think what I will do is on this quiz, I will add page 65 plus a couple of these difference of squares. Because before you leave today, you will see the right answers to a lot of this page. All right? Everybody cool? Okay, I'm going to take attendance. I haven't taken attendance yet today. I got to take all 4 classes. Then I'll start walking around. It is 1:55. I want to show you the right answers to this by 2:13. Because class goes till 2:24 or whatever. Right? So that gives you 20 minutes right now to do this. Okay? Yep. Most of these are one step in your head, aren't they?
Yeah.
Right? Go. Unless you don't know your square roots. Yep.
Mr. Myers,
Yo.
did we mark page 65 on Friday?
Did we mark page 65 on Friday?
Yeah.
Yep.
I marked it.
Well, it's probably on YouTube.
Okay, can I get a mark?
Yep. Okay, ladies and gentlemen. Follow along with what I am doing here, because there's the gong. When Ashminder walks by, you tell her the 2 numbers. Okay? There's the first 3. There should be no questions. The 2 is out front. It would multiply by everything.
Oh, I see. Okay.
Wait, okay. Are you making for like the 65 one? I got 11.5 out of 12.
Stop.
Yeah. Wait, and then the other one I got this one.
What are you doing? Why are you looking at me? Yeah.
We smart.
Any questions on 4, 5, and 6? I made quite a big deal out of it, but I'm recording it, Pardeep, so you needn't worry.
Wait, how did you get number 4? Oh, wait, no, never mind.
I've already stopped minding.
She never started.
What?
Oh my gosh, you did it.
It's x squared. 7's have a cross in the middle. Where would you get an x7 out of there?
Does a 3 do anything? Yeah, I'm gonna add a 7. Y'all understand?
Where, Addison?
Does a 3, so you're taking a UCF of 3 out of left and go 7, right? Does that have anything to do with the exponent of 2 on track?
No.
Doesn't do anything.
No.
Okay.
There is 7 through 9. Any questions?
Well, wait, I need to like see it.
It's all being recorded.
Oh, I'll email you notes what I have. That's like so much information to take in.
I GCF'd out of 3, and then I factored. There is 10 through 12.
Would I get a 0 on the assignment?
No, just omit it, or you can do it. But if you omit it, you're losing the possibility of getting assignment that you should get 100% on, because you know how to do it. And lastly,
I was right.
so just write an omit, OM. And there is number 13. It has all been recorded. You will notice I am not showing steps for anything except when I have GCF'd, because other than when you have taken out a GCF, it is just taking square roots. And all of these numbers are small enough that you should be able to square root them in your head. Braden, go.
The last one there, can't you take that down one more time?
2 doesn't have a square root. Yes, I'm fixing that right now. 2 has no square root. That's why I did it that way, because I was looking for somebody to try and do that. That's why it's not an assignment, because I threw 2 different tricks at you here. I threw the GCF trick at you, 3 different tricks actually. I threw the GCF trick at you, I threw a fraction trick at you, and I threw one that looks like you could carry on but couldn't. So now, since you've seen all this, on tomorrow's assignment, none of those tricks should get you. And on tomorrow's quiz. So, ladies and gentlemen, it has now been committed to this video recording twice. I wrote quiz tomorrow, and I am saying quiz tomorrow. Quiz tomorrow is on page 65 plus difference of squares. Yes, but the quiz tomorrow will have questions like page 65. That's why it says page 65 plus difference of squares, Addison.
I can see all the equations. Oh no, my motherly instincts are kicking in.
Motherly instincts? Honestly, I wouldn't know even motherly instincts.
Yo.
Go camping with someone with a camper, put a fishing line, 10 pound test at least, tie it to where you camp, put tension on it, get some skin on your fingers, and go in, vibrates their whole camper.
Okay.
It's funny, because they get so, you can't see it, it's fishing line.
Why would you want to mess with your friends like that?
Because it's my boss. That's who he locked in the camp. It was his idea to go mess with it. And then he walked in there. Chance to blow off your boss and something.
Well, since my boss is Mr. Como, I don't think he would take it as well. I would probably lock Mr. Sadu in something and be like, but
Mr. Sadu.
I wouldn't lock Mr. Como or Miss Berdini in anything.
Not Miss Berdini. She just kicked down the door.
Thanks, you're the best. That's a 4 out of 4 this week, sister. That's the stuff.
But yeah, when we went up to the Alps, a lot of it was a good road, but some of it was just so overgrown. We were just crashing through trees. It was fun though.
She lost all
Nice.
Yeah, she's still alive. Mr. Myers, can I put this in the recycling?
Sure.
There's 4 hours.